All right, good evening, everyone. Let's see, we're going to jump right into it. Tonight we are talking about the introduction to Flight Module 1 of Civil Air Patrol. We're going to be doing Chapter 2 tonight. And so Chapter 2 is called To Fly by the Lifting Power of Rising Air. And so what that is talking about is gliders. So let's move on. All right, so let's see here. We're going to go to the PowerPoint. Okay. As always, for just a quick introduction, my name is Lieutenant Bob Roberts. I'm with the Greenville, South Carolina Composite Squadron. We are doing individual lessons with each of the chapters for the 6 modules for Aerospace Dimensions. You can do any of these in any order that you would like. You do not have to do them starting at number 1. You don't have to do number 4. So if your squadron is doing them in a different order, please feel free to go ahead and stay with them. If you want to just stick with us, we're going to be starting at Chapter 1, Module 1, which we did last week, and we're doing Chapter 2 this week. We'll be doing hopefully a chapter a week. So next week we'll be doing 3, and that'll finish up Module 1. Then we'll be going to Module 2. Okay. So how to use the video series. Number 1, I recommend that you read the material first. It really helps to cement the ideas when you watch and listen to what we're talking about in the videos if you've already read the materials. I will say that this chapter in particular is pretty small. It's only a few pages long. We're going to go into a little bit more detail in the video series above and beyond, but hopefully you'll get some benefit out of that. So go ahead and read the chapter first and then come here, watch the video, then go back and review any of your notes and take that test, get the test done. All right, so here's our learning outcomes. Our learning outcomes are going to be describe how gliders use the environment to obtain altitude, describe why gliders look different than powered airplanes, discuss how gliders can achieve great distances without power. Those are going to be the 3 main topics we have. All right, we're going to move on. All right, so what are some of the differences that you see in between these types of airplanes? What are their primary uses? How do they interact with their environment? What do you notice about the size of their wings? What about their cockpit? How much usable space would you have inside of one of these? I'm 6'8". Would I fit in all of these? The answer is no, I would not fit in all these. I've tried. All right. So first thing obviously we notice is the wingspan. On the sailplane, that wingspan is massive. It's really long. On the glider, it's not quite as long. And on the powered aircraft, it's the shortest of the group. And it really tells you the type of aircraft it is. You can tell almost by looking at it in the sky, you can tell that's a glider versus a sailplane versus a powered aircraft. Sometimes you got to look a little closer between the glider and the sailplane, but you can really tell it. If you really look at those 2 airplanes, you can tell the difference. Sailplane, much bigger wing, much smaller fuselage. You don't have a lot of space inside that fuselage. The glider cockpit for me is very, very small, but compared to the sailplane, it's roomy. So what we're really trying to do with these different types of airplanes, we're looking at its glide ratio. So how far can it travel for, given a certain altitude? If we look at a sailplane, we're looking at give or take 60 to 1. So for, if it was up 1,000 feet, it could travel 60,000 feet that way. So as an example, if you were, 10,000 feet high, right? A mile is, little over 5,000 feet. So 10,000 feet high, you'd get about 100 miles. That's pretty good. And a glider, it's still pretty good, but not nearly as good as a sailplane. A glider is 28 to 1, give or take. And a powered aircraft like the Cessna is typically around a 9 to 1 glide ratio. So as you can see, a sailplane can go up quite a bit further than say a Cessna can. It can glide a lot farther, I should say, not how high it can go. Okay, so short piece of history here. So one of the first gliders we had of relevance was the Wright brothers glider. So of course we have the Wright brothers aircraft, the Kitty Hawk, in North Carolina, I'm sorry. And here they actually built a glider first, and that was done in 1900. Now they built 3 gliders. They're referred to as the 1900, the 1901, and the 1902, based on the years they were in. There's no real good estimate for how long it could glide for. They were still testing out, some of the forces of flight. And then in World War II, the Army gliders that you'll see in some of the history books and some of the aviation museums, those went about 12 to 1. So even though we saw those and they were pretty bulky, and you can see them here in this picture, they're being towed behind the powered aircraft. 12 to 1 still better than a Cessna. So Cessna being about 9 to 1, a little over 9 to 1. These were about 12 to 1. So these are actually quite a bit better than even a Cessna was. So for as bulky as they were, they actually did glide pretty well. All right. So real quickly, so the powered aircraft, they fly by generating thrust created by the engine. So these engines could be internal combustion engines, such as you have in a Cessna or a Piper. They could be jet engines like you see in airliners or fighter aircraft. They could be turboprop, which is a different type of thrust with the props. And then, if we look at the four forces of flight, thrust, going forward is one of those four forces. This is what gives powered aircraft their forward movement. And then that forward movement is what creates relative wind across the wing of the aircraft, which helps them to generate, lift based on downdraft and Bernoulli's principle and all the fun stuff that we talked about in Chapter 1. If the engine keeps running, you can keep flying. If you run out of fuel or if your engine stops, you start going down. And again, you're looking at about 8 to 10 feet forward for every foot that you are high. And so when I fly cross country, I actually tend to fly really high. I tend to try to fly around 10,000 feet if I'm going someplace far. And I do that because if my engine quits, I want to have a lot of choices on where I'm going to land the airplane. If I'm at 10,000 feet, that gives me roughly, depending on the wind and some other stuff, gives me about 15 miles. So if I were to look at a map from the time my engine fails, I'm at 10,000 feet, I got 15 miles I can go. So that's pretty good. You can usually find at least a small place to land within 15 miles. So now let's take a look at gliders. So gliders have no thrust, right? So here's a picture of a glider being towed up. So the glider will actually be, again, towed up, and the tow plane will bring it up to a certain altitude, and there's a cable that's attached to it, and the cable will, there's a little release, and the release will open when they get to the right altitude, and then the glider's on its own. Now, the gliders can take some advantage of the air and any vents and thermals. They lift it, but it doesn't take as much as a sailplane. So pretty much as soon as that glider is let go, it starts coming back to the ground. Again, you're looking at about a 25 to 30 to 1 ratio. And so that's pretty good, though, because if you were flying at 10,000 feet, you could fly for 50 miles. So if the tow plane took you up that high, you can fly for quite a while. Because these airplanes don't go that fast to begin with, so they can hang in the air a little bit. Also, I want to point out there's when we talk about altitude, we talk about two different things. We have MSL, which is mean sea level, so that's how high above it are you from the sea level, and then AGL is above ground level. So I've done most of my flying up in the New York area, in Rochester, New York, and the airport is about 600 feet above sea level. And so when somebody would say, I'm at 1,000 feet, well, are you 1,000 feet above the ground? Or are you 1,600 feet above the sea? Or are you 1,000 feet above the sea, but only 400 feet above the ground? And so you have to really pay attention. In a lot of the maps, you have to pay attention to what you're looking at. When they tell you an altitude of a mountain, are they telling you MSL or AGL? It can really matter. Okay, now let's go on to sailplanes. So sailplanes, again, like a glider, they have no thrust. They develop all their initial movements, again, by the use of a tow plane. The big difference with a sailplane is designed to take advantage of its environment. It's designed to take advantage of the thermals far more than, say, a glider is. You could, if you can continue to find lift in the air, you could conceivably stay up almost indefinitely. Eventually you want to come to the ground to, get something to drink, get something to eat, but you could stay up for the air for quite a long time. And, if they even ran out of lifting air, let's just say the air completely dies, they can't find any more thermals, they lift them up into the air. If they were at 10,000 feet, they could fly for about 100 miles. That's really pretty great. People have taken sailplanes on cross-country trips. Okay, so the books want you to know the parts of the airplanes. The parts of the gliders and the sailplanes are about the same as they are with any other aircraft, with two notable exceptions, obviously. One, you typically don't have an engine on board. I have seen some gliders that have a very small engine that's on the back just to give them a little bit of power, but typically they don't have much. But the big difference between the aircraft is that a glider and a sailplane will have a speed brake. And here you can see a speed brake is just a big piece of metal that they stick into the air. So this way, if the glider wants to come down fast, or sailplane comes down fast, if they were going to overshoot their runway, they want to come down faster, they'll initiate the speed brake so that they can go down faster and lose a lot of speed. So they're either not gaining speed while they're going down, or they're going to drop the speed if they're going a little too fast on landing. Also, you'll find some other aircraft have speed brakes as well. You'll find a lot of fighter jets will have speed brakes. You'll notice that when a jet airplane lands, you'll notice on the wings they'll have flaps that'll basically, instead of flaps going down, they'll have flaps that pop up. That helps to stop it. One of the most impressive speed brakes I've ever seen is actually on the space shuttle when it was flying. Pretty impressive because that space shuttle, it lands really fast. It landed like a brick. So they used the speed brakes to slow it down once it got, once they knew where they were going to make their runway. All right. So how do we get these thermals for these, especially these sailplanes? How do we get these thermals? So 93 million miles away, we have this really bright object called the sun. And that sun will send us its energy. And so when the sun hits the ground, it will heat up the ground, and different places heat up faster, depending on the type of surface. And so the areas that are heating up faster, the air will rise faster than the other air around it. And so if the airplane, the glider or sailplane gets itself inside of there, it literally, even though the glider itself relatively to the air is still coming down, the air it's in is rising. So it's going to circle in that air, and it's going to keep rising and rising and rising. And they've actually shown that some of the sailplanes have gotten up to 25,000 feet just by rising air, which is pretty impressive. And so a lot of times if you're in a sailplane, and sometimes with gliders, they will hunt, right? So the fun of that flying is to hunt for those thermals, try to find where they're going to get the next lift. Because again, if they get 10,000 feet of lift, they just got themselves, almost another 100 miles that they could travel without finding another thermal. So again, you can fly cross country, in a sailplane when you know what you're doing. Again, that was one thing. So you get lift caused by the sun hitting the ground, lifting up the air. The other two ways that you can do it is if the wind is being pushed up a mountainside, you'll see a lot of glider clubs that base their clubs right next to some type of a hill or mountain range. And that's because as the air gets pushed up the mountain range, well, a glider can sit there and it can follow along that rise. And then on the other side of the mountain, when it comes back down, it'll kind of wave, right? Just like you would see ripples in the lake. If you throw a rock into it, you'll see big waves right in the beginning, and then you'll see as the circle of the waves trickles out, you'll see smaller and smaller waves. Well, the sailplanes, if the pilot's really skilled, they'll know where that up wave is versus where the down wave is, and they'll circle in that up wave for as much as they can. Now, they can't get tons and tons of space because unlike thermals that just keep going up until the sun comes, until that air comes back down. The mountain waves, they're only so high depending on the size of the mountain, so they can only get that height. So one thing that the book talks about is the temperature rate. So for every 1,000 feet you go up, now this is going to be different, right? So this is just an average. But on average, for every 1,000 feet that you go up, you are looking at about a 3.5 degree Fahrenheit drop. Or 2 degrees Celsius for our friends in Canada and just about everybody else in the world. But for us in the U.S., where we look at Fahrenheit, it's a give or take about 3.5 degrees Fahrenheit per 1,000 feet. So what does that mean? So that means if it was 72 degrees when you took off, if you were cruising with me on a long distance trip and I went to 10,000 feet, it'd be 37 degrees. And so if you showed up and you were in a T-shirt and shorts, I can warn you that the airplane that I have most of my flying in is very drafty. It's like, even though we close the doors, it's like the wind just comes in one side of the airplane and just gets shooted out the other side. And so, you could get, 30 degrees, 20 degrees, and it was nice on the ground. And it could get pretty chilly up in the air. So always bring a jacket, even if it's nice on the ground. Always bring a jacket. Now, if you're going to do a lot of flying with CAP, they're not, for your flights, they're not going to take you up most likely at 10,000 feet, unless you're in like Colorado or someplace. You're not going to get to 10,000 feet. But if you're flying long distance with somebody, they might take you up higher speed. And so that's why when you look at, say, in World War II, if you take a look at the bomber pilots, and this is a great picture of a B-17 crew, for all on the ground where they were standing, it was 80 degrees. But they're going to fly at 20,000 feet. And so it's literally freezing when they get up, and they didn't have, they had big holes in the side of the airplane, they stick their guns out of. So they had to dress warm because it could be very, very cold for them. All right. So again, here just about the convection process. So we kind of talked about this earlier. So the sun will hit the ground. Now the different surfaces will heat up faster, and the skilled pilots know what those surfaces are. So when they're looking down at the ground, they'll say, oh, there's a road there, and the road's going to heat up faster than the grass around it. So I'm going to go try to find the thermal that's coming off of that. Now, what will happen now is that hot air will rise, and then it'll get to a certain point where as it's cooling off, it'll start becoming the same temperature as the air around it. And then that air actually will come back down, and it'll circulate. It'll come back down to the ground. It'll mix back up with that hot surface, and then it keeps rising and keeps going around and around and around. And so if we have two types of air, we have stable air, we have unstable air. So a stable air mass will actually prevent that, right? So that movement up will be very slow. So glider pilots don't like stable air. They want unstable air because the air will move much more rapidly than the stable air will. Now, general aviation pilots like myself, we want stable air because we don't want that bumpiness. We don't want the air moving up and down on us. So that's the convection process. Okay. So here's the thing. So if you're really thinking about soaring in a glider, let your team know. Let your CAP team know. Your commanders, your cadet commanders, your senior members. Let them know you're interested in that. That there is actually flight academies specifically for gliders. And as a glider pilot, you can actually start flying. You can solo at a much younger age than you can a powered aircraft, which actually to me almost seems not the right way, right? Because you don't have an engine. So you've got to really know what you're doing to make sure you make the runway. But listen, all these glider pilots, even the younger ones, they do a great job at it. So it must be wonderful. Now I wish I could fly a glider. I'm 6'8", so I don't. If anybody knows of a glider that I can fly in, let me know. I'll fly out to you. I'll fly across the country if I can fit in your glider. I would love to fly in a glider just to have that silence and know that I'm soaring through the sky, with the birds and not that loud engine noise in the background. It's got to really be great. So if you are interested in that kind of an experience and you're a cadet, let your senior members, let your cadet leadership know. Okay. So, all right, that's really pretty much it for the lesson. It was a relatively short lesson tonight, short chapter. So again, now we should look at these outcomes again, make sure that we achieve these outcomes. So describe how gliders use the environment to obtain altitude. We talked about that. Describe why gliders look different than powered airplanes. So we talked about the wings and about the speed brake, the size of the fuselage. There's not a lot of room in the sailplane and glider, so they really make use of every pound that thing weighs. Discuss how gliders can achieve great distances without power. Again, we talked about the thermals, about the lifting forces, and the fact that you have a long glide ratio of roughly 60-1 for the sailplanes, give or take a little less than 30-1 for a glider. And as compared to a powered aircraft, which is, the Cessna is about 9. Sometimes you can get as good as 11 or 12. And so, all right, some important terms. We'll just go through, since we already had a short lesson, we'll just read through these real quick. So altitude, the height or distance above a reference plane. Again, we talked about above sea level and above mean sea level, and also above ground level, AGL. Convection is the fluid motion between regions of heating. Again, that's where we talked about if one part of the ground heats faster than the other parts around it, that will rise faster. You can get lift there. Density, that's just how thick something is. if you, like, for instance, if you had 12 eggs in a basket, as opposed to if you took half those eggs out, you would have 6 eggs in a basket. The basket is still the same size, but you have less eggs in it. So there's your density. Your glider ratio, we talked about it a couple of times. How far can you go depending on how high you are? Your lapse rate, that's the temperature that we were talking about. Give or take on average, not always the same. On average, 3.5 degrees Fahrenheit per 1,000 feet, or 2 degrees Celsius if you're in the metric system. Soaring, that is the art of staying aloft by exploiting the energy in the atmosphere. Again, we talked about the thermals. We talked about the ridge waves, mountain lift. Stability, there we talked about stable versus unstable air. Stable air means it's hard for the thermals to climb up. The air wants to resist it, as opposed to unstable. The air can move up and down pretty freely. And glider pilots like unstable air. Thermals, that's just we talked about a couple times, the air going straight up. And a tow plane, that's a powered aircraft that can tow a sailplane and a glider plane up to a certain altitude and then can let it go. And then a wave. This is the mountain wave that we talked about. So you get up and down, up and down, up and down. The tow planes and gliders will the gliders and the sailplanes will try to find the up part of the wave, and it will sit in that to get altitude. And that is it. All right, so hands-on. So if you want to do a hands-on lesson, 2 things. So number 1, there is an actual hands-on glider that's in the book. You can print it out. You can make it out of styrofoam if you want. See how that works. What I would like to see you do is try to make a paper airplane. And so with your paper airplane, see how far you can make it go. Now, this is a pretty standard thing for paper airplane. But what I want you to do is I actually want you to measure how high you are off the ground, say in inches. So let's say you throw it at 4 feet high. Well, that's 48 inches. See how far it goes and measure how long it is before it hits the ground. And then measure how many inches that is. And then divide the 2, and that will give you your glide ratio for your paper airplane. And also try putting a paper clip in a couple different spots, especially on the bottom, to try to change the weight between the nose versus the back. See how that helps you. And then try different weights of paper clips, some bigger paper clips, some smaller ones. And then here's just a picture. If you do a search on paper airplanes online, you can find all of these different types of paper airplanes. Try to make a couple of them. See which ones glide better than others, and see if you can come up with in your mind, well, why? Why would that paper airplane glide better than the others? So that is our lesson for tonight. Again, kind of a short lesson. We try to keep the chapter lessons on the aerospace modules, aerospace dimension modules, down to about 30 minutes. So we're doing pretty good. We had about 25 minutes on this one. If you have any questions, feel free to paste those in the chat or down below. And if you could do me a favor to help other CAP members find these videos, please go ahead and give this video a like. And if you want to know when we're doing additional videos, go ahead and subscribe to the channel and hit the bell icon. And then we usually do our lessons right now Monday nights at 7 o'clock while we're not meeting. For those of you that may be years out in the future, this is being recorded when we have the coronavirus. So everybody's home. So on Monday nights at 7 o'clock, we're going to go live with our main squadron aerospace lessons. Everybody's welcome to join. And then on Friday nights, until we finish these, we're going to continue with the aerospace dimensions classes at 7 o'clock. With that, thank you very much. Again, my name was Bob Roberts, and I hope you all have a wonderful day. Thanks so much. Bye.